Since we, one of the big reasons I want to do the Talking Science with you is since we last talked, a lot has happened. Are you keeping up with any of this Pluto stuff?
Kind of. I'm not like an expert on it or anything.
Well, what have you? Because here's what I've seen, and tell me like what this means. Like they were freaking out one day. I was reading an article about it, trying to figure out why it was such a big deal. But they discovered, like through the picture, and I guess they were surprised by it, that there's like mountain ranges and caverns, and mountain ranges is as high as like the Rockies, and caverns deeper than anything we have on Earth. And why they said it was a big deal, and I still don't fully understand it, is it showed that there was geological activity on Pluto. So why is that? Like, wouldn't that just be like any planet would have geological activity, right? Why is that a big deal?
Well, no. For such a small planet, its core wouldn't have stayed molten very long, and so geological activity is actually not expected.
So does that mean it still has an active core?
I doubt it, but I mean, it does have a moon that's fairly large-ish compared to the size of it.
Yeah.
So that helps.
Why does a moon help a core? Because of gravitational pull or what?
Yeah, it creates tidal forces inside the planet that keeps things moving. It doesn't let it settle.
So that would form some of these caverns and things like that.
Right. Yeah. I mean, on Earth it'd be like plate tectonic type stuff, but I don't think they expect that much activity on Pluto.
But there had to be some serious activity because they said some of these caverns were like 3 to 5 miles deep. Like they were unexpectedly, like they were deeper than any caverns we have here, is what they were saying.
Right.
But I guess if they didn't have an active core, then like you could probably have, like you couldn't have that deep a cavern on Earth or it would start spewing lava, right?
No, that's not quite deep enough, but it's getting there.
Yeah. I mean, that would be dangerously deep to go on Earth, right? 5 miles deep would be... how...
Things start getting a little weird down there.
How deep can you go? Like, if it's just me, like a Bugs Bunny cartoon, Bugs Bunny has a shovel and digs to China.
If Bugs Bunny just starts digging towards Australia.
How deep could you go before, like, because they dig, I mean, under the ocean, they have drilling and stuff. How deep can you drill before you get into, like, okay, we're messing, things are getting dangerous territory?
Well, eventually it starts getting rather hot. I know that there's a mine in Mexico that goes really deep, and down in the bottom of that mine, it's hot. Like, they have to wear special suits and
for like heat suits?
Yeah. And they have to, and it's like way below the water table, and they have to pump out all this water every day, or the whole thing would just fill with water. I don't know if you've seen, they've done a couple specials on some different shows.
What is this? Why do they have a mine this deep? What are they doing?
I'm trying to remember what they're mining for.
So they have I guarantee you, the people going down there.
I'm wanting to.
They're a step below the kids who make our iPhones. Like, they are sending people down for very little money. They're like,
I'm sure.
They're paying them 3 cents an hour to wear a heat suit and go into the old gypsum mine 3 miles under the core.
Okay, so I actually have my laptop today, so I went and Googled how thick is the Earth's crust.
Okay.
20 to 30 miles thick on the continental crust.
That's the crust. So this is if it's the skin. Because keep in mind, when we talk science, you're talking to a moron here. The skin it's like the epidermis of the Earth, right?
Right. Yeah.
Okay. So the crust is the epidermis. So okay, so you're as soon as you get below that, you're getting into the I don't know what you're getting into, but you got outer crust, inner crust, right?
Yeah. I mean, there's different layers, and they're defined in different ways. And
what's below the crust?
They actually just recently found a new layer in the mantle where things change density.
That sounds crazy. So you've got the outer crust, you got the crust, 20 to 30 miles.
Yeah.
Then what do you have under the crust?
Well, I mean, it just depends on how specific you want to be.
Let's keep it fair. Let's keep it general, like. I
mean, generally, okay. You have crust, then you have mantle.
Okay.
Then you have outer core, which is liquid, and you have inner core, which is solid.
Wait, so it's like, you know, when you get a tennis ball or whatever, or a baseball is a better one, and it has all the string if you've uncovered it, and then at the very bottom of that string, there's like a little hard rubber ball. That's what's like in the center of our Earth.
Yeah.
What the hell is that made of? Because that's got to be subject to nothing. It's surrounded by lava, isn't it? Like burning
magma.
Yeah, it's surrounded by magma. So it's this burning, churning rock. Like, isn't that what the sun is made of? Magma?
No, the sun is made of plasma.
Oh, okay. What's the damn thing? What's the core made out of? What is that?
Well, we don't know for sure, but it's
we need some of that, dude. We could do
like
some
heavier
stuff with
metal, like iron, nickel. They think is the biggest two.
So it's this hard ball of metal right in the center.
Yeah, but it's solid because of the pressure.
So, like when you get down to the bottom of the ocean, how your face, like if you just did a deep dive and you could breathe that long, at some point your ribs would crush and your skull would mush. It's like the same thing, right?
Yeah. Well, kind of, yeah.
So it's not hard because it can withstand the heat of magma. It's hard because it's got so much pushing against it from every angle.
Right.
Okay. But it can't be melted, the center. The material that's in the center.
It could be if it got hot enough, but at the heat that it's at and the pressure that it's at, it's a solid.
Are those things completely, like, is a thing's melting point and a thing's pressure completely and totally interrelated? Like if I had a cube of ice and I had its melting point at room temperature, but then I increased the pressure in the room, would its melting point change?
Yeah.
Oh, I had no idea. I did not know this. So
there's like a little triangle of temperature, pressure, and volume.
Okay. So like again, with the size of the block of ice matters.
Any change in one will affect the others.
So that's why you can have, like, when you're on a frozen lake, you can go skate out on a deeply frozen lake with no worries, even though it's somewhere at the bottom it turns to water. It's because it's such a large volume of frozen ice.
Not exactly, no.
I'm confusing a lot of things right now. I'm trying to understand, though. So, okay.
Okay, so you have an equation where I think it's PV over T, pressure times volume divided by temperature.
Okay.
Okay, and it has to, generally it's going to remain constant, like within a system.
Yeah.
So like one way to think about it is, so you've used the canned air stuff to clean with, right?
Yep. I've zapped the keyboard with that, yeah.
And whenever you hold it down for a long time, it gets cold.
Yeah.
Right?
That's correct.
Okay, so your pressure is increasing, and so is the volume. Okay, so you have your PV over T.
Okay.
So pressure times volume over temperature.
Okay.
So the pressure is decreasing. The volume is drastically increasing because it's going from a liquid to a gas.
Okay.
Okay? And so in order to keep that whole thing constant,
it has to reduce the temperature.
The temperature has to reduce.
Wow. Wow. This is some crazy shit, dude. And so that explains why we can have a core that is solid surrounded by magma. Under other circumstances, nickel's melting point would be different, but because it is so much pressure, it can withstand a lot more heat.
Right.
Okay. I think I've
got our core is about the same temperature as the surface of the sun.
Wow. So you're going down.
Of course, the surface of the sun is actually significantly cooler than the corona.
What is the corona? Is that the around the sun, like the little?
Yeah.
So wait, if you could get through the corona, which is that why the beer is named Corona? Is it just because like you drink it in the sun? Is that what that is?
I don't know if those are. Well, I don't think so. No. I'm not sure. I'm sure they both have a similar Latin root. I have a feeling it has to do with like a crown or halo.
Oh, okay. Because I was just thinking that was like I could be drinking.
Guessing.
Whenever I'm drinking a Corona, I'm like, I'm drinking science beer. Do you know what a Corona is? Because I will say that from now. I will bring up the fact what a Corona is when I'm drinking Corona now. Corona is the outer layer of the sun.
Yeah.
Which is the hottest part of it.
The hottest part.
If you could,
no, it's not the hottest part, but it's hotter than the surface.
The hottest part is probably the core of the mantle or the, what is it? The right around the outer core of the sun is probably the hottest part of the sun.
The hottest part is probably the inner core, but we don't really know for sure because it's a little hard to get to. But we can assume.
If we could put on a heat suit like the slave laborers in...
And the middle of the sun would also be full of heavy elements.
Well, I don't even know. Okay, so wait, let me get my question. There's so much to talk about the sun. All right, so if we could, like the slave laborers who have to go to that mine in Mexico we talked about before, who wear the crazy heat suits and go to the earth for $3 an hour.
Dude, you should really look into this place. Like,
I've got to find out what they do here.
They broke into a cave full of crystals that are like these gypsum crystals that are like 60 feet long and like they're like giant tree trunk sized crystals.
You're talking about the mine in Mexico, right?
Yeah.
Yeah. This is crazy shit, dude.
It's like 120 in that little cave where those crystals are. I say little. It's like the size of a football field.
Yeah. How scary would it be to be that far down and in that? You know, they would be probably awesome, but probably freaky too. Because there's like, if the earth just went like, we're gonna close this up right now, you're done. You know, like it's over. Would you go down there?
Would I go down there?
Yeah.
I don't know, maybe. So that mine is, or that cave is 980 feet deep.
That's it?
Yeah.
So it's not even a mile?
No, not even a quarter of a mile.
And that's one of the deepest mines out there, right? Have we never been a mile down?
Like, has a person ever been a mile down?
Anything. Like, it just seems like we're doing all this space exploration. Why aren't we just dropping shit down and seeing how far we can go?
Because space is easier to get to.
I think we should do some... If I was... You know what? I don't know if anybody buy into this, but if I was president, I feel like I would say, like, we're done with the outer space. Now we're going inner Earth. We're really gonna... Can you imagine the technologies we could come up with if we put billions of dollars behind inner Earth exploration? Like,
okay,
no one would get as excited. Everybody would clap about Mars. No one would clap if I said, all I want to do is get a mile down. No one would be excited about that.
No, and that's the other thing. Like, nobody really cares.
I'd love to be a mile
The only people that care about going deep is oil exploration, and I think that's too far.
Well, you probably passed the oil at that point. Now you're just getting into weird. But imagine if we could fuel things on magma. Boy, we should get down to maybe we could drill magma and use that to power things with heat.
That's called geothermal heat, and I forget which one of the Nordic area countries it is, but one of them gets most of their power from heat from geothermal energy.
Sounds like something we should be looking into. All right, I interrupted you though. You were telling me about the Mexican mine. I'm sorry.
So in the mine, in the crystal cave thing,
yeah,
and it's gypsum, which is that's what and now I've completely lost my word.
Well, I know this. I have a brother-in-law who works for a gypsum mine.
Sheetrock.
Sheetrock. Okay. Yeah.
So down there where all those crazy giant crystals are, which I guess the largest one is 40 feet long and 13 feet thick.
Yeah.
It's usually around 136 degrees with 90 to 99% humidity.
Holy moly. Holy moly. So that's why they need the suits.
Yeah.
So
people can only be in there about 10 minutes at a time without a suit.
Wow. Boy, they found that out the hard way, didn't they? The 10 minutes at a time. Some poor people died in the... I always think about that and everything. Like, there's a certain amount of, scientific discovery and advancement that involves, just poor people being thrown to the slaughter. You know what I'm saying? Like we talked about the pyramids, or we talked about this mine. Like, the only way they discover these things is by saying, hey, I'll give you $10 to go see what happens. And this guy, $10 means something to that guy, so he rolls the dice. That's how they figure that shit out, man. It's awful.
That's how discoveries are made. Somebody has to be willing to do it.
And it's always a poor person. It's always a serf. You know, it's always
yeah. The rich people have too much to lose.